are Team 6. I'm Surendhar and he's Josh. So the project is about an automated lumber block scanner. So this is inspired because it's more tedious work to measure like a huge chunk of blocks. So just to save some time on it, we plan to make an automated system for it. So to start with, I would go with the panel. On the panel, we have the PLC, and like we have some relays, but we are not using that. And we are using a modem to connect and communicate with the operating station, which is the laptop. And and we are using like 3 sensors to measure the dimension. So to start with, I would go with the rotational encoder, that is to measure the length, and you can find an ultrasonic that we are using to measure the thickness of the block, and there's another laser sensor which you are using to measure the width of it. So going over to the trial, you would start to explain about it.
All right, so we're going to go ahead and run the board through right quick. And then we've got the hand measured dimensions of the board, and then we'll show the calculated dimensions. So when we put it in, the ultrasonic sensor detects the board, and that enables the encoder. And then the board spins over it. The encoder has a spring tension on it, which keeps it going up. You can kind of see it bounce back. And then the width measurement also is enabled whenever it's sensed. So the board, hand measured, is 4 inches wide, 48.5 inches long, and about 1 3/8 inches thick. In nominal measurements, it would be considered a 5/4 board, just based on how they sell lumber. So the calculated board foot would be 1.68. So based on what we calculated, the width calculated is 3.85 roughly. The length is roughly 43, and the thickness is 1.35. And then the calculated board foot would be 1.4. So part of our discrepancy here is that the two planes, feeding and receiving the board, aren't quite coplanar with the measurement plane. So that little bit of tippage causes the encoder not to pick up every single rotation. So that's where some of the discrepancy in the length comes from. So if that was to be fixed with solid metal or rollers, that should alleviate a lot of that. Otherwise, the thickness and the width is pretty close, and the total board foot would be in benefit for a customer. Less board foot would be less cost. So future things that we would want to do is look at like an AR solution. So one thing we would do is add some sort of edge computing device with a Kepler server, and then we could put AR markers throughout the system, and you could use either a mobile phone, a tablet, or something like HoloLens to see real-time values of, like, say, the sensor measurements, or we could even take a look at the RPMs that the board is being fed, and then have the board feet being reported as well. One other thing that would be highly beneficial is, as the board comes out, having, like, say, a barcode scanner that puts the dimensions as well as the total cost of the boards, and then it would also move that inventory into like a inventory database with the dimensions as well as cost. So yeah.